everybody. I am here to introduce the next speaker. You heard from her a little earlier this morning. She is the director of the USA National Phenology Network. She is also an associate professor at the University of Arizona. And she is coming up for an encore conversation as to the fantastic world of phenology. The title of her talk will be From Flowers to Forecast: Why Phenology Matters.
Thank you. Okay, sorry. We're going, where'd everything go? Where'd all the plants go? There's no microphone? Can you guys hear me okay? Okay, I'll just kind of hang tight. I'll stand right here. Thank you again for having me, and I'm really glad there was a break between Patrick's talk and mine, because I was like, oh man, I can't go after that guy. That was incredible. It was really, really fantastic. And I already knew that I loved this crowd. I've spoken now at several tree care conferences and ISA events, and man, I just love it even more. You guys are amazing. Oh, thanks. Is it on? Does this work? Okay, I'm gonna do that. I feel less tied down. That's good. Okay, so this is the talk that probably would have been the better one to have in the morning, because you're probably all still sitting there thinking, what is phenology and why do I care about this, and who is this person and why is she here? So I am here to tell you about that now, which is honestly, truly my passion. So it's spring, at least where I live in Tucson. I am seeing lots of signs of spring. I walked around here in Albuquerque yesterday and a little bit today. I'm not seeing as many signs of spring here yet, though I hear it's been warm and not very rainy or snowy. In Tucson, it's been a really interesting winter and early spring. This is the center picture here. This is Civano Canyon, which is in the Catalina Mountains just north of town. And we've had wonderful rain all through October, November, December, January, which is honestly actually kind of novel for us. We do have a bimodal precipitation regime there, where typically we have a summer monsoon rainfall season and then a winter rainfall season again. But the last several years, they just have not cooperated at all, and it's been like a monsoon and then crummy winter rainfall. So this fall and winter, we are so grateful. And the plants and the animals are really responding, and in kind of interesting ways. The upper left photo there is mosses, and they are so green. They're so green. The hill slopes are just covered in green mosses, which is very strange, honestly, for a desert, a low desert environment. On hikes I've recently seen, in December actually, I saw pipevine swallowtail butterflies and several tarantulas, male tarantulas out, which is honestly kind of odd for December, late December. Both of these actually are more like summertime monsoon active critters. We tend to see them in like August, September. So it was a little strange to see them in December. And then we've got some buds that are maybe close to bursting. And then on my most recent hike, I started to see what I have been anticipating with all this rain is a lot of annuals. We tend to see really fantastic winter annuals and spring annuals when we have good winter rain, fall and winter rain. And this is not a great picture, but those are California poppies. And we're starting to see them, and the lupins and other things show up. And it's really exciting. And then we've got this crazy situation going on. This is a house in my neighborhood which traditionally has these African daisies or gazanias that tend to come up. They are going absolutely gangbusters this year. It's a little crazy, honestly. They're kind of trickling into the neighbors' yards, up and down the street, and it's much more intense than it usually is. The thing that's notable about this, though, is that some of these events that I mentioned are much later than we typically see them, and other ones are remarkably early, actually. I always think of the gazanias as like kind of a harbinger of spring in my neighborhood, and I think I usually see them in at least mid-February, which I realize we're in now. But I started to see these guys coming up at the end of December, and I was like, this is weird. So I started to chat with my husband about it because he's a climatologist, and he reminded me, well, this December has actually been the warmest December in Tucson that we've had in ever, and we've had this great rain. And so the species are all kind of responding in different ways. Some are finally kind of picking up their activity late because they finally got that rainfall that they were waiting for the last several months. And other ones are responding by going early because they got the warmth that they needed much earlier than they were expecting. Basically, what I just described there is what phenology is. It refers to when seasonal events like bloom or hatch or activity in animals occurs, and what are the environmental conditions that seem to trigger or drive or cue that event. And we can basically think of it as seasonality and the seasonality of events, but we have both kind of, there's two things attached to that. There's one piece of the puzzle where we can pretty much predict that some events are always going to occur at a certain time of the year. Certain events are springtime events or summertime events or fall events, and they typically can be relied upon to occur at those seasons. But then there's more variability in when they actually occur. Sometimes it varies by days, and sometimes it's by weeks or more, and that's really the function of what the weather is like. And so the reasons behind this are basically the fact that we have an Earth that is on a tilted axis, and we are revolving around the sun. And so at different times of the year, the northern hemisphere is either pointed toward the sun, which lends us to having longer days and warmer temperatures, or other times of the year we're pointed away from the sun, and that's when we have our shorter days and our cooler temperatures. This is consistent. This is totally reliable from one year to the next where the Earth is going to be on that revolution around the sun. And so therefore we have defined and predictable seasons, warm periods and cold periods. But then it gets a lot more complicated because we also have an atmosphere. And the atmosphere is basically this lovely blanket that surrounds the planet and allows us to have life on Earth because it protects us from the radiation coming in from the sun, and it provides nice oxygen that we can breathe. And then it creates weather. It kind of moves around in these very large scale cells. And because we are, again, the Earth is rotating, creating our days and nights, that causes all these different wind currents at the high level and low level. And I'm not going to get into it because I'm not an atmospheric person at all, but it makes it much harder to predict what the conditions are going to be actually from one year to the next, or even one day to the next sometimes. We humans, though, we've been paying attention to this, the fact that biological events are actually predictable to some extent and tied to environmental conditions for as long as we've been on the planet. And we've got some pretty cool evidence of that being the case. And even when we didn't have the ability to track things like the temperature with thermometers and other technology like that, we still had the ability to be able to pin down what was happening and use it in a very predictive and decision-making kind of way. And so if you're a gardener, you may be familiar with some of these kind of phrases or adages that sometimes get circulated. One of the most common that I hear is to plant corn when the oak leaves are the size of a squirrel's ear, or sometimes a mouse's ear, some kind of small mammal. And I've heard others too, like plant the peas when the peepers are peeping, and if you Google it, they're endless. Those sound quaint, and sometimes they're even labeled folklore, but they actually have their roots in wisdom, in native traditions, and because our indigenous ancestors didn't have anything but their abilities to observe and pay attention and understand and keep track of things to help mitigate their very survival. And so this adage or this phrasing, this wisdom, actually works, and you can kind of reconstruct it because what the prediction is trying to help you understand is you don't want to put the corn seeds into the ground too early because then you risk them rotting. They can just be in there and get wet and frozen and rot, and then you don't have a crop. You don't want to put them in the ground too late because then you may not have sufficient time for the crops to come to full ripening and have the most abundant crop that you can achieve before the sun starts getting lower and you have, fall onset. So what they kind of figured out through trial and error is this situation where oak leaves are starting to come out is a good indicator that we are past the risk of major freeze events. Oaks are actually a tree, you guys, again, probably know this better than I do. Oaks are trees that don't put their leaves on real early in the year, largely. They are kind of a later season species to come online. And so that's a good indicator that, okay, by the time the oaks are coming out, the leaves are coming out, we are in that territory where it's relatively safe to get those seeds in the ground. And actually, you can also pinpoint when the oak leaves come out to a growing degree day threshold, and then figure out what that actually equates to in terms of corn development, which I do in my book. So if you're interested in seeing how that plays out, it's out there. Some other really interesting evidence that we've been keeping track of this stuff for a very long time traces back to cave paintings. Some of these are from, this particular group of images are from Europe, some dating back as old as 40,000 years. And it was only really recently identified that these symbols that look like dots or dashes, for a very long time, folks didn't know what those referred to. And recently, some anthropologists believe that they've cracked the code on that, and that those refer to moons, and moons can basically be a form of calendar. And so they tracked the moons. The ancient people that painted these kept track of the moons, and they could use that as an indicator for when different animals that they relied upon for food and shelter and medicines were going to be mating or migrating through or having their young, and so therefore really relevant for their survival again. We have some other really fascinating evidence of where folks have kept track of things, and I imagine that there's lots more that we haven't unearthed yet, but this one's pretty fascinating. In Japan, you might know that they're kind of crazy about cherry blossoms. It's a really big deal, and I understand why, because cherry blossoms are just an incredible phenomenon. You get that all the flowers open at once. They flower before they leaf out, so you get these like incredible pink and white and fuchsia canopies, and they're very ephemeral. And that's kind of one of the reasons that they're celebrated, is that it draws our attention to the ephemeral nature of nature, of life. And so monks, starting with monks, but folks have been keeping track of when the cherry trees flower in Japan for a very, very long time, with an awful lot of dedication. And in some cases, uninterrupted for things like 1,200 years. And so this plot here comes from Kyoto, Japan, where folks have tracked, I believe this is the date of peak bloom, when the cherry trees have flowered, when they've reached peak bloom, in each year, starting in the 800s. So we have over 1,200 years here of when the cherry trees have flowered. And what we're looking at, so it's year along the x-axis, it's day of year, calendar year on the y-axis, and then the pink dot represents the date that that event was recorded. And then there's this wiggly black line going through there, which is a moving average. What we can see pretty clearly here is that the date varies a lot from year to year, and that goes back to the fact that weather, air circulation, it's hard to predict. We don't know exactly what's going to happen in any given year. And historically, those cherry trees reached peak flower anywhere from the end of March to the beginning of May. And then along comes that thing called the Industrial Revolution, when we started pumping an awful lot of particulate matter and carbon dioxide and other greenhouse gases into the atmosphere. And we see this pretty clear trend of that flowering creeping earlier and earlier and earlier. And I wish that the folks that put this graph together would update it, because the other dots are all clumped down here too. Basically, we can see the record here that phenology varied pretty clearly, but kind of a lot from one year to the next, until we started changing the composition of the atmosphere, and then we start to see a pretty clear trend in one direction. And when we layer that on top of things like global temperatures, it further kind of corroborates that story. So this plot here actually is only focusing on the latter half of the previous one. We're starting at 1880 here now and running through 2020. This was put together by our friends at NASA, and what they calculated was the average global temperature in each year, starting back from 1880 and going up to almost present. So you take the whole globe and you figure out what the temperature was over the whole globe and average it for the whole year. And then what they did was take the average of those numbers in the 1951 to 1980 window. So that's another one of those climatological periods that's 30 years. That's a standard that they do. And they said, okay, let's take each year, the global average temperature in each year, and compare it to what that average temperature was from that 1951 to 1980. And so this is the difference. And so if you see a blue bar that's pointing downward, that means that the average global temperature in that year was less than or lower than that 1951 to 1980 average. And if it's an orange or red bar pointing upwards, it was warmer than that average period. And so there's, again, kind of a clear pattern here that it was cooler back in the late 1880s, and it is pretty much just, with some variation, I'll give you that, pretty clear uphill trend. And again, we're still seeing variation, and we experience this variation in terms of what feels like a warm year or a cool year to us, but overall, the planet has this upward trend in temperature. And so, because, like I said this morning, so many of those seasonal events that we see in plants and animals are so closely tied to temperature, we see a lot of those events starting to shift. And the trickiest part here is that we don't have great data in a lot of places. But where we do, there has been some recent work, and this has really only been in the last few decades. This research has started to come online really right around the turn of the millennium, so early 2000s. And forward. What I'm showing here, I'm not going to do very many graphs in this one, I promise, but this one I will walk you through because it was the best summary graph I could find for this. This was a paper that was published just at the end of 2024. What these researchers did was pull data from as many continents as they could find it for, and then look at whether the timing of activity has shifted. And if so, has it shifted earlier or has it shifted later in either the last 10 years, the last 20 years, or the last 30 years. So I'll walk you through this. Starting at the bottom, these are all just plant phenophases. We look at budburst first. And what these plots are a histogram. So the higher the bar, you can envision this as a bar, they're smoothed, but it's a bar, it's a count, basically. And what we're looking at across the x-axis is whether things have shifted earlier. If it's a negative number, that means that the timing of the event has shifted earlier. And if it's a positive number, it's shifted later. And then we have three different color, what is that shape? Humps here. The dark colors are the ones that were calculated using 30 years of data, which you can see is smaller because we have fewer long-term records of that length. The middle shade in each one is where they had 20 years of data, and the lightest shade is where it's a shorter record, usually 10 years. What we're looking to see is, okay, first off, in this particular plot, we see a lot of the counts are on the negative side, meaning an awful lot of those records that were evaluated depicted shifts toward earlier activity, earlier budburst. But there were also a lot that actually exhibited shifts later. And that is true regardless of whether we were looking at just 10 years, 20 years, or 30 years of data. But the peak of the hump is shifted to the left of the zero line, which means that we have a greater preponderance of things that are shifting earlier than things that are shifting later. What's interesting is then when we start progressing upward, which is kind of moving through the season, we first largely experience budburst. I know some plants flower before they leaf out, but bear with me. Largely things leaf out before they flower. When we get to leafing, we see the same sort of pattern, but the peak is further to the left, meaning that there's even more of a shift. There's a greater preponderance for species to have advanced than have delayed, and it's by a greater magnitude. There's greater shifts that are occurring in that later phenophase. And then when we get to flowering, it's even more true, where things are even further shifting further earlier. And then when we get to the fruiting, yet again, or fruit ripening, it's even further, and then it kind of falls apart with the leaf sequence. What these authors argued, though, is that because plant activity, each phenophase or each event is a function of when the previous thing occurred, this is actually depicting what's the right word? It's kind of like a cascading effect that's occurring through the season. So each subsequent event is experiencing an even greater magnitude of a shift than the first one. But basically, the take-home message here is that we do see a lot of things shifting earlier at a global scale. How much it's shifting, meaning the magnitude across the x-axis, varies a huge amount. Some things are shifting by 30 days, some are very little or not at all. Some are shifting later, again, huge magnitude shift. And it really varies depending on which event you're looking at. So this makes a muddle, honestly. We are not seeing entire communities shifting their activity one direction or another. Everybody's doing something different, which is making a muddle. I really debated about this. I didn't put the animal plots on there because they were so messy. They were so messy. And the trouble is, too, animals are much harder for us to evaluate because they don't sit still. So these data here, these plant data, largely come from very dedicated people who have been tracking what's happening at a single location on oftentimes the same individual plant, which is a huge lift, but it's possible because plants sit still. But animals don't, and so it's really hard to try to get good data on migratory bird arrivals or insect emergences or mammal young bearing and all those different things. And so what I didn't point out yet, the sample size over here is on the right, the N, and so this means they had 18,000 unique series that they were looking at for evaluating bud burst, and they had, 138,000 for flowering, which is not uncommon. Everybody likes to look at flowers more than anything else. When we were looking at the bird and the insect and the mammal ones, they were like a few thousand. So it's just a lot messier, a lot less data, and just a huge opportunity for us to still continue to try to understand better what's changing. But if we still want to try to wrap our arms around how things are changing at a very high level, one way to look at it is it also depends on what region you're looking at or what time period or even which seasonal event. I did my best to try to kind of collate all of that, and I was able to come up with by looking at these meta-analyses like the last one where they pull together data from so many different studies. Just since the 1980s, at a global scale, we've seen a shift on average of about 4 days in just springtime activity. So that may not sound like a lot, but again, we have the very messiness of it. And so that actually means some things are shifting a huge amount and some not so much. Okay, but how do we know? In some very limited places, we have really amazing records like that cherry blossom record. But largely, we do not. And largely, we've only really started paying attention to this stuff since we started to realize, oh, stuff might be changing. So what are we doing? There are certainly scientific studies like the program that I run where we're trying to get people out on the ground making observations. But that only means that if we get someone starting now, then we can look at basically from now until whenever they stop, going forward. But we really need to know what happened in the past, and do we have any records and information that we can rely upon for looking backwards too. And so we try to get creative here. Journals, notebooks, documentation. You know what's crazy? People sometimes look at things like photos, graduation photos, or recurring events that have been documented. There's footage from a bike race, I think in France, where it's happened on the same weekend every year, and some folks have gone in and noticed the trees are all leafed out now at the time of that event. And when we started doing this bicycle event several decades ago, the trees were bare. Isn't that interesting? So this takes a lot of nuance to really make sense of somebody's personal records, but they can actually be a really valuable source of information. Satellites can be a good source of information, though we really only put the first satellites up in the late 1960s, early 1970s, and those were at a very coarse scale. So our ability to get really long-term records from that are pretty limited. Observations, people making those observations on the ground are a very important source of information. And then one more source of information that is kind of recently came online that really helps us look backwards in time is herbarium records. And what those are smashed plants. Basically, hearkening back to explorers' time, but this is still a practice that is done now, people will collect samples of plants and then press them and preserve them to document sometimes just what species exist. And definitely when plants can't be identified, the samples are collected so that they can be identified, and sometimes that's how we document new species. And they're also widely used for understanding where different species can be found, so establishing their distributions. One of the really fantastic things about them is that they always have this little information card in the corner that gives both information on where they were collected and when they were collected. So we have a snapshot in time of where a plant was. And then the other really magical thing about it is that oftentimes, really the best records are collected when there are flowers or fruits present. As many of the botanical structures as can be present are tried. Folks try to capture those, and the reason is that those are so important for identifying the species. And so, if you are able to find a herbarium record that has flowers open on it, like this one, and then you can interpret what that card down there says about where and when it was collected, you have a point in time record of when that plant was in flower, or if it had fruit on it, then when it was in fruit. And so, folks, there's huge efforts underway right now to digitize these records and document the phenological status, meaning are the flowers open or not, are their buds open or not, are their fruits open or not, to be able to kind of build out some of those historical records. And then looking at when we are able to assemble some of those historical records, then we can take present day records and compare them to see how things have changed. And that kind of work is very much underway right now. And I will share just a few examples. I could go on and on all day. This particular result comes from New York. And very interestingly, in the state of New York, there was actually this really intense effort back in the early 1800s, preceding the Civil War by a lot, to document when plants were undergoing leaf out and flowering in the spring, based at all these academic institutions across the state. And that was because they didn't have weather stations yet. And the equipment was really expensive, and it wasn't standardized yet, and people hadn't agreed on even what variables to track. They were not consistent about how they did it, but they knew it was important, and they kind of were aware, well, how warm it is and how wet it's been does seem to have some sort of relationship with what we see our trees and our shrubs doing. And so there was this pretty substantial effort that stretched for decades that had very, very rigorous data collection on documenting when different trees and shrubs were leafing out and flowering all across the state. And those records were only very recently unearthed and digitized again. They were all captured in annals, which was amazing, in all these historical documents, but someone had to scan them and then transcribe them and get them into spreadsheets. And then we compared those historical data from 150 years ago to observations collected recently, compared them all, and saw that every single tree or shrub species that we compared had shifted its flowering and leaf out time earlier. But again, how much they shifted varied enormously. And one of the ones that really stood out to me was tulip tree, which is one of my favorite trees. I love it so much. It now flowers almost a month earlier than it did. Back in I think it was like the 1820, 30, 40 period. So that is dramatic. That's a major shift. And we basically attributed it to the increase in temperature that we've experienced over that period. However, again, it's messy. We don't have that same pattern in every part of the world or in every species. Going across the pond over to Switzerland, where they've also had some really good uninterrupted long-term data collection, some trees, like horse chestnut, have only shifted their phenology, the timing of their activity, by just a little over 10 days. And so, while that doesn't sound very impressive compared to the tulip trees, it still has the potential to have substantial impacts on ecosystem functioning, and most interestingly, is so different than what we're seeing over here. And these changes, of course, extend to animals too. I know I said animal data are harder to come by, and they're messier often, but there are definitely single location studies that have run for a long time uninterrupted, and there are also good databases that folks are putting a lot of effort into compiling and pulling records and signal from. This was one that really stood out to me because emergence of reptiles that undergo, they're ectotherms, I got corrected on this, they're ectotherms, and they brumate, which isn't the same as hibernating, but they basically go dormant for the winter. They go underground, they hang out until it's basically warm enough that they can come out and move around safely, move themselves out of danger if they need to, and find food. Well, the weather in Europe is a whole lot more erratic than it used to be, and the folks that are studying the snakes there are now reporting that the European adder is coming out almost a month earlier than it used to, much to its detriment, because if it comes out and then it gets cold again, those poor snakes can't move. They're kind of literally frozen, and they have a hard time finding food. So this is a bad news thing for these guys. And I'm a terrestrial person, I'm a plant person. I have really had, going into looking at all this stuff, I had no idea what to expect for animals. And definitely, I was curious to know what's happening in marine and aquatic environments. So I started researching, and I was amazed that in Narragansett Bay, they're off of Rhode Island, they have been doing, the University of Rhode Island has been doing these surveys of the fish in the bay on a weekly basis, uninterrupted, since the 1950s. And so they know what fish are there every week. And some folks did this analysis to see whether that has changed. And I just about fell off my chair when I saw this, because it was not in a very high-profile journal, which I had to check this like 5 times. Some of these fish, okay, so the temperature of the ocean varies a lot from over the course of the year. I didn't really realize this, so I'm going to tell you guys, because maybe you didn't know either. There's ocean currents, and the ocean temperature actually varies even more than the air temperature does. And so there are absolutely summer resident fish and winter resident fish, and they follow their thermal tolerance, and so that's why they migrate. And just since the 1950s, which is not even 100 years, this little guy, the longhorn sculpin, who's a winter resident, has shortened its stay by 118 days. And that's not the only fish. His brethren that are also the wintertime residents, several of the others, which include, oh, I'm so glad I have the notes here, ocean pout, red hake, a couple of others, they have shortened their stays by 90 days. So 3 months less time spent in that bay than they used to. And then on the flip side, the summer residents are staying much longer, anywhere between 30 and 80 days longer than they used to. So that just kind of blew my mind. But like I showed in that first colorful, complicated slide, there are plenty of species that are shifting later, too. Not everybody is shifting earlier, and this is an example from one of the Dakotas where there was a really good record that some farm folks had recorded on their property for no reason, definitely not motivated by science or global change. They just liked keeping track of when stuff happened. They took really good records. Some researchers out of the one of the universities there happened to find it. I actually don't know how he did. And so he had a grad student, and they went out and resampled, basically looked for the same species of plants and when they flowered and leafed out about 100 years later. And they documented variable changes. It was not like the story where we saw in New York where everything shifted earlier. In this case, it was kind of more variable, and smooth sumac, which is a pretty common shrubby thing there, shifted its flowering time 10 days later. So, go figure. And there are some distinct consequences for this, for sure. Definitely for being a non-responder or an uncooperator. For species that aren't basically tracking climate change or that increase in temperature, they are largely kind of losing out, meaning that they're not as common on the landscape than they used to be. And one of the best studies that set of results that we have for this comes from Henry David Thoreau, the guy that wrote Civil Disobedience and lived in his shack in Walden Pond. He actually also took extremely good records of when he saw different species in flower and when birds arrived in the spring and all sorts of stuff. And he just tromped all around that part of the country, wherever he could walk, for several years and took meticulous records. Again, they were lost until somebody didn't lose them. They unlost them, they found them, they digitized them, they had to make sense of his messy handwriting, and started to repeat that same thing, going out, tromping around Walden Pond, looking for different species. And what those researchers out of Boston University found was that the species that are not exhibiting big shifts, that are basically flowering or leafing out at the same time that Thoreau documented them, are far less common on the landscape. Some of them are gone altogether now. And the ones that have showed the most dramatic shifts, like blueberries and viburnum, those guys are very common on the landscape. So they're basically winning from keeping pace with the warmer temperatures. Okay, so lots of things are changing, and I kind of hinted at the fact that this has implications for ecological functioning and structure and that kind of thing. There are also very clear economic consequences of changes in phenology too. And this is what I end up usually having to talk about because this is where people actually start to listen. When we start to have mismatches in things like when pollinators are present and when the plants that need those pollinators present aren't lining up, we can start to see pretty distinct impacts in things like agriculture. We're now, this is tricky, this is a harder one to pin solely on climate change because we're also seeing this massive decline overall in the number of insects that are out and about. But many large-scale farms are now having to truck in bees at particular times to make sure that their crops are getting populated. And it's really hard to document this kind of thing, but there have definitely been some studies that have documented that, yes, we are seeing a shift where in Japan, the flowers are coming out before the bees that need them. And in Spain, we're seeing the opposite. And it's starting to create a problem. Another consequence that we see from this advance toward earlier behavior is a risk of being decimated by frost, by freeze events. That's what is called false spring, where plants the ones that don't care about day length, they just respond to any old warmth they get exposed to, really stand to suffer the most. And we see this very clearly in crops like cherries and almonds and peaches are a different story, but plums, things that flower before they leaf out in particular, and that put on their flowers early in the season and are a high-value crop. And we've had some recent years where they've just been decimated because it's been very warm very early in the year. The trees respond to that warmth by opening up their flowers. That really tender tissue doesn't do so great when we have an ice storm come through. And I know I don't have to tell you guys, if you kill your flowers, then you're not going to have fruit. And so there was a year in the last decade, something like $500 million was lost in cherries in Michigan, and several other smaller scale events, but notable because of this situation of more erratic spring sequences. And then allergies. Has anybody felt like their allergies are worse? Because if they feel worse to you now than they have in the last few decades, you're not imagining things. To kind of oversimplify, when we put more carbon dioxide in the air and we pump just make it warmer, the plants are growing bigger and making more pollen. And definitely, I want to clarify, it's not all the plants that cause our allergies. It's largely the wind-pollinated plants, and those are the ones that generally don't have very attractive-looking flowers. So this picture drives me crazy because that's a misnomer, actually. But there's a study recently that documented that since the 1990s, we've seen the pollen season, the season during which those wind-pollinated plants are producing pollen and releasing it into the air, has extended by almost 3 weeks. And the amount of pollen that they're pumping out into the air has increased by about 20%. So we are not imagining it if it feels like it's a longer, more intense allergy season. But it's not all bad news. I can never just leave everything all bad news. There are some upsides to that longer growing season too. And these are probably things that you're familiar with. When you have trees and plants growing, it's a good thing. They provide shade, they provide carbon sequestration, they slow runoff, they improve the air quality by pulling the carbon dioxide out of the air. And if we have a longer growing season, an upside is that we can experience these ecosystem services for a longer period of time. So it's not a slam dunk. I will not say that having a longer growing season is a good thing because it leads to greater carbon sequestration and all as well because it's more complicated than that. But there are some upsides. And for sure, we can all enjoy having leaves on the trees for longer. But what I usually get faced with is, okay, so what can I do about all this? Is there a role that I can play? And that is where the organization that I lead comes into play. Again, late 1990s, early 2000s is when the scientific community really started to recognize that, yes, the climate is warming, the globe is getting warmer, and actually we're starting to see clear evidence of it. And changes in phenology was the first way that we could tangibly see the impacts of a warmer climate. And so it really was, again, looking at things like that cherry blossom graph that started to grab people's attention, and they started to recognize, okay, we may not see, it may take us a very long time to start to see species, especially plants, move where they're found, which is one of the ways that we anticipate seeing the implications of a changing climate. But we can see right away now that, yes, stuff's leafing out earlier than it used to, or in some cases, birds are arriving earlier than they used to. And there are phenology networks in other countries that have been around for a lot longer, and so a lot of those lines of evidence were coming from Europe and China and Japan. We here in the US largely didn't have long-term monitoring until 2007, when our network was created through a collaboration with the US Geological Survey and the University of Arizona. And so what we do is basically collect, store, and then freely share data and information about when stuff happens seasonally in plants and animals. And we do that to support our basic understanding of what's going on and how it's changing and what the consequences of that might be, to support more real-time decision-making, like the phenology maps and the growing degree day maps that I showed earlier today, to communicate and connect and help people know what the heck phenology is and why it matters. And then, I still like to say this, even though the feds are having a hard time with some of this language, we really are intending to ensure that the work that we do benefits everybody in the country and beyond. So one of the primary activities that we do, besides the maps and products that I showed this morning, is host this platform called Nature's Notebook. And it is intended to engage anybody in professional scientists, volunteers, folks of really any age or skill level in documenting what you see happening in plants and animals at some location. We say your yard, but just something that's very accessible. Because what we're really looking to do is build a long-term record over the course of the season, and ideally from one year to the next, of when things are happening. The intent is to generate data that really are of sufficient rigor and quality that they can be used in those applications that I said earlier. And so for that reason, we're a little different than, say, iNaturalist or some of the other programs that will let you observe and report on anything you see. We kind of are a little more, snotty, I guess. What's the right word for that? We have a list of about 2,000 species of plants and animals that we have specific observation protocols for that we ask you to follow to make those reports. And then we have extensive forms of training and engagement and ways to bring folks on board and connect you with others for making those observations. And then we also have resources for accessing those data, either raw or visualizing it online or downloading it, whatever your skill level is, we try to meet you there. And one of the things that we've really invested in too is you can participate in as an individual, or you can participate as part of a local group. And we have hundreds of those kinds of groups across the country now, and they have been phenomenal. And there's some right here in Albuquerque that have been active for well over a decade with extreme levels of commitment. And it is just so amazing to see what has come out of this, both from the data side, but even more fascinating to me, what the observers' experiences have been, how rewarding they report that it is, and how much they gain from being a part of this activity and from connecting with others and exchanging information, and the discovery that they experience, and how they learn to see so much more than they had seen in the past, and how that's applicable to the rest of their lives. And I'm having a great time talking with people about participating in this. And it's building an incredible quantity of data. It's just mind-blowing to me. We have close to 50 million records that have been contributed now since the platform launched in 2009. And what this map is showing is all the locations where data have been submitted, and then the size and color of the circle represents how many records. And so you can kind of see there's a bias toward where population is concentrated for sure. And then there are certain locations where there's far more data than others. But I want to point out that a lot of those large circles are those local groups, those groups, like the ones based here in Albuquerque that have stuck with it for so long. And speaking of that, there's a little tool on our website that if you're interested in trying to find out what groups are in existence in your area, it's a little map-based tool, and you can zoom in and click on those points. And so I zoomed into Albuquerque, well, all of New Mexico to see what was there, and then I clicked on Albuquerque in particular, and there are several these are what we call local phenology programs, or LPPs. And you can see that there's gray ones, which were ones that have historically collected data but don't seem like they're active right now, and then green ones that are active right now. And if you're interested, you can go in there and even learn more about them by clicking on their profile and then connecting up with them and joining if you're interested. And for fun, I'm going to drill just a little bit deep into this, use these guys as an example because they are one of those phenomenal groups. The Albuquerque Biopark Phenology Team consists of these 6 individuals, and some of them are in the room. Judith and Carl and several others that I'm so anxious to meet tomorrow. They have been observing at this location at the biopark. They have 4 distinct sites, and they track 12 species of plants, 22 individual plants, and they have been tracking there every Monday for the last 12 years, which is just such an amazing record. I'm going to tell them tomorrow that you guys are cheering for them. So these are some of the species. I didn't fit them all on here, but some of the species that they observe. And I will be talking about this a lot more at a different meeting tomorrow, but just for fun, this is just a taste of what this kind of dedication, and I don't even want to frame it that way necessarily, this kind of activity can lead to. What I plotted here, I forgot I did have a few graphs. What I plotted here was, this is for one of their plants, stretchberry. We plotted, we have the year on the x-axis, and then, I'm sorry, I don't have it labeled, the day of year on the y-axis. So 90 is somewhere around March 1st, and 110 is 20 days later. This is spring, basically. And what we're looking at is leaves on this plot, flowers, open flowers. This is when flowers open here. And each dot is a particular observation. So it's one of, I think they have multiple stretchberry individuals, and the dot represents when did they first see leaves on one of those individuals in that year. And so that's why if you look down, some years have multiple dots, and that's because there were multiple plants. And if they're clumped together, that's because both plants were observed on the same day of year first. And looking over their period of record of 12 years, we can see that actually it looks like, this is the question we always get. We always get from our participants is, well, are things changing? Can you see evidence of change in the data? We've been collecting these observations for you for, in this case, 12 years. What can you tell us? And so I was really happy to be able to dive into their data and poke around a little bit. And we could see that, well, yes, it looks like there's a bit of a trend when we run a trend line through this, but our confidence interval, which is this green blob around it, is pretty wide, which means this is a weak trend, and our confidence interval, this one overlaps 0. We have a negative and a positive value. So that means it's not statistically significant. And so unfortunately, this is one where I have to say we have to keep observing if we want to know if it actually is drifting, in this case, later. That is, an upward trend means it's trending later in the year over that period of record. However, when we look at the timing of flowering, that one, the confidence interval is tighter, and when we look at the confidence interval values, they do not straddle 0, which means that this is statistically significant. And so over the period of record that these folks have been observing stretchberry, they have documented that it's flowering later in the year now than it used to be. Okay, so why? Everybody always wants to know, oh, I circled that. Why? That's always the next question. Okay, well, that's the fun part. That's where we try to start connecting it with the environmental variables. And because if we were in New York or somewhere in the East, I would just attribute it to temperature, and it probably wouldn't be that hard. But we're in a water-limited environment here, and so it's more complicated. So I had an analyst who helped me with this, and we looked at seasonal precipitation totals and monthly average or seasonal temperature and precip. And what we saw was if we looked at the 6-month winter precipitation, so this is a slightly different plot now. This is not time anymore. This is the relationship between how much precipitation we have within the previous 6 months. I think it was September to February. Yes, September to February, so winter. How much precip fell during that period, and then the day of the year. And so what this means, the black line is the average for the whole period and all the plants. What this means is that the greater the precip over that period, that 6 month period, the earlier the event occurs. And we can actually, again, calculate the slope, if I have my son to help me with this. We see flowers open 3.2 days earlier for every additional 10 millimeters of precipitation that falls within that 6 month period. So the take-home message here is we see earlier flowering when we have wetter winters. So if we go back here and we look at what was actually happening, where the flowering was drifting later, this suggests to me that we've actually been having drier winters than trending toward drier over this period. And also now that we have this relationship established that was significant, we can use it in a predictive way. And so it's tricky because a 6 month precip is hard to use in a predictive manner, but you could say, okay, if winter looks like it's starting off wet, that might mean that we're going to see earlier flowering in the subsequent spring. Okay, I don't know where I'm at with time, so I probably need to hurry up. One of the things that we are starting to see, and this is where just one example, I could talk forever because we've had well over 200 peer-reviewed scientific manuscripts now that have used the data that have been contributed to Nature's Notebook to tell stories and investigate how things are changing. One of the things that researchers have definitely documented is that in urban areas where it tends to be warmer, we tend to see things like earlier leaf out and later leaf fall. And yes, that generally has been attributed to the fact that urban areas tend to retain heat because of all the impervious surfaces and asphalt and that kind of thing. Some researchers recently said, though, well, we know that plants actually, many, not all, many plants pay attention to light too. So could we investigate whether artificial light is playing a role? And so what they did, what we're seeing here is the dots on the map are the observations of leaf out that were contributed to Nature's Notebook without anyone who was contributing these data having any idea that this study was going to take place. And then on the right, same thing, but for leaf fall, colored leaves. So all those, and we see Albuquerque is represented in here, so I'm pretty sure that the data that our local team has collected were a part of this study and helped make it possible. What we've got this plotted on top of is a satellite collected depiction of artificial light. So you can see huge blobs of where big cities fall. And so what they did was basically do a comparative analysis for the urban areas and the rural areas, accounting for latitude and elevation, because those two things also are major effects on when things leaf out or drop their leaves. And what they found was that in the urban areas, the effect was about 6 days. And they actually figured out that it is much more the effect of the artificial light than it is the heat. The light is actually the more important variable. So that's just, I love that example because it's one example of a really important result that would not have been possible if we didn't have all these volunteers collecting and contributing all these data in good faith, believing that their data would be used in some way at some point for something. And so now what we're trying to do at the network is close the loop and figure out who was it that submitted all those observations and let them know. One of the things that we've always done is these publication summaries, where whenever papers get published using the data, we do a little public-friendly summary. We take the scientific paper and try to translate into accessible language, which has always been nice, and we try to let people know through our newsletters and things. But now we're trying to say, okay, whose records were they? Email them and tell them you specifically contributed to this, making this study possible. There are a whole bunch of these on our website if you're interested in exploring how these data have been used. And then quickly, I will mention, if you're so inclined, all of the data, the 50 million records that I mentioned, are accessible. If you're real savvy, you can pull it through APIs and analyze it in R. If that doesn't mean anything to you, don't worry about it. You can also make cool plots on our website through a visualization tool and look at how different species respond within a year or across years, what they're doing across latitude, which is sometimes fun to do as the year is unfolding. And the data are available real time in that tool online. If you're excited about participating and you haven't signed up yet, I want to let you know that the app is undergoing a major overhaul, major good thing, and we needed it so badly, and we're on the very verge of releasing the new version. and if you do use it, I'll just kind of mention some of the enhancements. One of the big ones is that you can choose the level at which you participate. One huge thing is you'll be able to see all your plants on the map if you are observing plants, because plants are fixed, and then this will utilize the GPS in your device and help you navigate to them, which is kind of cool. And then the protocols are kind of complicated right now. We ask you a whole bunch of questions about a whole bunch of things, and you can opt out. You can reduce the complexity. You can basically say, I only want to answer the simple questions, and there's no judgment about that. And that actually makes it far more appropriate and accessible to more populations, including younger people. So that's one of the huge reasons why we pushed in that direction. Right now, the internal deadline for releasing this is mid-March, but my team would not let me put a date on the slide. What I can promise, though, is that if you're interested, you should definitely sign up for newsletters on our website. I don't think I have this right here. If you go to the website, usanpn.org, and scroll down to the bottom, you'll see the Get Our Newsletters tag. You can also download the app now. The old app is still available, and it will continue to run for some amount of time in parallel with the new one. And at some point, and again, this is all very active shifting sands, at some point, we will message folks using the old app and say, hey, there's a new app available, go download it. And then eventually we'll force everybody over to the new app. So that'll be all happening at some point this spring. So if you're not doing it yet, I might recommend hang on. Just hang on, it's coming, and I guarantee we will be letting everybody know loudly through social media and our newsletters and all the rest once we're finally comfortable inviting the masses to get involved. One other thing I will mention really quickly is that we also usually host a series of online stuff the week of the vernal equinox to celebrate Phenology Week. And so we will have some online talks and trainings with the new app and that kind of stuff. Again, that will be advertised on our website and through the newsletters too. I don't think we have a landing page on the website just yet, but it will be going up very soon. And so, gosh, I hope I didn't go way over. I welcome you to join us. I hope that I have encouraged you that phenology is fun. Here are some opportunities for ways to get connected or get more information. And I will be out in the lobby. If you haven't been hit over the head enough with this, I'm out there with that. And the book basically is a much more expanded version of what I tried to cover here today. Thank you.
Teresa's actually early. If anybody has questions, we got 5 minutes.
Okay, good. Woo! I had no idea.
So who's got questions?
Oh, oops, did I do that?
Questions. Going once, twice, sold. Go get a book. So we got a speaker right now, right?
Okay, thank you so much. Oh.
So on behalf of our Nature's Notebook team and Think Trees and Albuquerque, thank you so much for everything you do.
Great.